Welcome to today's presentation, Automate Security in Any Environment with Chef InSpec. Let's go ahead. Alan, why don't you kick us off?
Hey, thank you, April. First of all, I'd like to introduce myself. I'm Alan Baptista, I'm Product Marketing Director here at Chef, specifically focused on Chef InSpec and Chef Automate. So it's a great pleasure to see so many of our customers and prospects attending this webinar. It's really going to be interesting. And with us, we also have Jerry Aldridge, our in-house InSpec expert, I like to call him, but I'll let him do his proper introduction.
Yeah, thanks, Alan. Yeah, I'm Jerry, former InSpec maintainer, transformed into a professional services consultant.
Cool. Thank you. So as we start, I'm gonna start covering some of the basics, some of the kind of issues around security and compliance and how, and then Jerry will kind of cover some of the InSpec details and specifically how to leverage both InSpec with an Ansible based tool. So as we start, digital transformation is basically taking over our IT. It's here. It's radically speeding up the pace of business, and it's increasing the demands placed on modern application teams, right, to deliver new expertises, new experiences, business value a lot faster. It's a reality that rewards the swiftness and agility that we're able to provide. Businesses that shape and outperform these evolving customers' demand will be the leaders in the coming years. But speed is nothing without proper security, without proper controls, or moving faster simply means developers may be actually releasing security vulnerabilities faster. So just faster for faster's sake is not really the ultimate goal. This increasing pace of rapid innovation isn't going to slow down really in reality. Organizations have really to master the shipping software faster with higher efficiency and a lower risk. The primary defense to ensure the safety and speed work together is to test for compliance throughout the agile, lean, and DevOps principles, what we call ALDO. These ALDO principles really drive the digital transformation. And as a result, we see that DevOps is eating the world of IT. A recent RightScale report found that 78% of IT organizations are in some phase of DevOps adoption. Should you be practicing continuous delivery following ALDO principles? The answer is most definitely obvious. Sure, but here's the real question. Can you deliver everything continuously and still remain compliant with information security standards? Most information security teams simply aren't set up to move with the high velocity that everyone knows it. InfoSec is still perceived to be an inhibitor of agility and speed, although IT operation professionals, 81%, say that they believe InfoSec slows them down. And InfoSec overwhelmingly agree. We know the state of things today simply isn't going to work tomorrow. So as we see this, despite the velocity and efficiency gains in other parts of DevOps organization, as we mentioned, InfoSec has mostly continued to lag behind. InfoSec policies are slow to implement, slow to audit, and they're firmly situated in practices that predate the shift towards this originating around the high velocity efforts that we see today. Industry data tells us that these postures are largely ineffective. Say 99% of vulnerabilities exploited are those that InfoSec has known about for at least a year or more. And it's predicted that the trend will continue through 2020. In 2014, for example, a handful of known vulnerabilities accounted for 99% of exploits observed in the wild. The number is better in 2017, but the inertia to fix that across the industry points to a remarkable lack of agility amongst information security teams. Furthermore, if vulnerabilities or compliance violations are discovered, over half of them can't respond quickly enough to patch their systems. And 1 in 4 organizations needs weeks or months to remediate them. In a world where dozens and hundreds of builds a day are deployed to production, that need to reconcile the information security aspects is really a deterrent to the speed of deliveries. And so this is a challenge because goals in most organizations are fundamentally misaligned. DevOps teams are focused to shipping software faster and increasing speed, whereas information security teams are focused really on mitigating risk. So historically, these goals have been viewed as by the IT industry as opposed, really. And we're constrained by the bound of this graph as the increased speed with error rates jumps exponentially, so with a greater risk. You can instead focus on lowering the risk, but in that requires additional time and sacrifices the speed, really. But years of industry data show that this perception or assumption is a fabrication and a myth. High-performance or high elite performing teams, as defined by DORA, prove that they can manage to scale both speed and quality. We tend to think that these constraints are true from experience, but the secret to shattering these constraints is using automation and involving information security earlier in the development process and phase. So high-performing or elite performing teams manage to scale, both because that shift allows them to build quality and security into the software, into the SDLC process as part of that daily work, rather than retrofitting and bolting and on security at the end. So that comes from the aspect that historically, traditionally, that's where that approach has been seen. Inherent cause of these problems is after the dev and ops have done their work and with due diligence and testing and preparing the stage, the whole process basically halts for a security review. And then any addressable needs will then be pushed out to the developer or testing team who once more process their efforts. And these security reviews are often manually done and slow and generate too much data from scanning-oriented approaches. So they catch problems too late in the development process and to economically fix, where it's a lot easier and faster to fix those when you're in the process as you're working through the development. So how do you see this waste of time being improved? Well, one thing we like to talk is how continuous automation, where organizations can have the best of both worlds, speed and quality. And we see continuous automation as really automating the application lifecycle, or especially defining its code, the full stack of infrastructure and compliance policies, which we're going to cover specifically in this webinar, through code and application dependencies. And why code? Code is trusted, it's collaborative, it's consistent, it's scalable and shareable. So it's something that can definitely be used from a perspective, but more importantly, that code can be delivered in a pipeline, in an automated fashion, which will help reduce the friction from delivering ideas to the ultimate shipment of that final product, which enables a scale of innovation with a fast feedback. You shift all the testing and security elements to the left and ease the burden on the IO teams. You eliminate unnecessary security and compliance gates throughout the process because you're already doing it automatically. You're establishing this repeatable process and obviously delivering that innovation, which we all want to do a lot faster. And in this case, we want to talk to you about how continuous compliance with Chef InSpec is important for that ultimate success in becoming what we call the coded enterprise. So, Jerry, I think this is where I hand it off to your expertise.
Yeah, thanks, Alan. So Chef InSpec. Chef InSpec, from a high level, helps express security and compliance requirements as code, allowing these to be directly incorporated into a continuous compliance automation process. By translating compliance into code, you unequivocally express the intent of these security policies. Like Alan alluded to earlier, the resulting code is not subject to interpretation, and the results speak for themselves. Essentially, by using Chef InSpec, you're able to shift the security testing left from the later phases, which are usually near production, all the way back to build and test, or even the developer's workstation. An example of this is shown on the right. Take the CIS benchmark. The CIS benchmark for this particular control states that systems shall have a mandatory access control system installed and enabled. Now, how this compliance requirement is fulfilled is open to interpretation. With Chef InSpec, we can codify the intent of this compliance requirement in a way that is unequivocal, for example, by stating that libSELinux should be installed. So like Alan mentioned earlier, a key piece to compliance automation is to scan early and to scan often in your software development lifecycle. Instead of performing compliance scans during security review right before deploying to production, Chef InSpec enables you to test continuously as you move from one stage to the next. This eliminates the rework that often happens with the old approach and allows everyone from dev to QA to ops to security to all be on the same page. To assist with this, Chef InSpec comes with several compliance profiles. As you can see here, there are several benchmarks from the Center for Internet Security already available. In fact, Chef is the first CIS partner certified in all 3 of the major cloud platforms. These shareable profiles can be consumed by any team across your organization. Compliance auditors can use them to automate manual processes and remove the guesswork associated with the auditor's interpretation of the policy. And DevOps teams can use these profiles in their development workflow, allowing them to verify InfoSec requirements via small automated tests with fast feedback loops that can be applied frequently throughout every phase of development. Taking this concept further, Chef InSpec, it isn't just limited to security automation. Consider the diagram on the left. Whether it be through spreadsheets, shell scripts, or configuration management tools like Chef Infra or Ansible, each team has its own way to express their intent. Chef InSpec bridges the gap between these teams and provides a common language to express intent. So rather than reinforcing the silos with each team maintaining a separate posture for meeting their needs, a code-driven approach via Chef InSpec encourages collaboration and builds on the existing methods already in use. Each team will still have its own tools and processes that must be followed, but a common posture, in this case Chef InSpec, lowers the barriers and introduces a shared mechanism by which teams can communicate asynchronously at scale. So Chef InSpec enables this collaboration at scale by using the same language for a variety of use cases. To elaborate on the configuration management example, Chef InSpec can both be used for the testing the result of configuration management code, as well as ensuring the entire process remains compliant with security requirements throughout the software development lifecycle. Using the same language for both of these use cases codifies each user's intent in a way that can be understood by everyone, regardless of the team they are on. Take these 2 code snippets above. The user on the left's intent is to verify that the website is deployed, the website they deployed is serving the correct content. In this case, they are asserting that the HTTP response body of the website they deployed contains the phrase "inspec in any environment." Whereas the user on the right is not so much concerned with the content of the website, but instead that the SSL v3 protocol is not enabled on the web server. This would ensure that the web server is not vulnerable to, say, Poodle, which would allow an attacker to view the plain text content of encrypted data. Now, setting the security use case aside for a moment, let's look at some examples of how InSpec can be used with any configuration management utility. So in this example, the left side shows the Chef Infra code used to install an Apache HTTP server package, start and enable the HTTP service, and deploy an example website. On the right is the corresponding Chef InSpec code. You can see here there's a one-to-one mapping of InSpec resources to actions taken by the configuration management. For example, asserting the package is installed, that a service is started and running, and that the file exists with the expected content. Now, here's the same example, but instead of using Chef Infra, Ansible is used to perform the tasks of installing the HTTP server, starting and enabling the HTTP service, and deploying the example website. You notice that the code on the right does not change. Regardless of the automation used, Chef InSpec can validate the results. Now, that being said, slides are great and all, but they're just that, slides. Let's walk through a more real-world example. For the following demo, we're going to use Test Kitchen to show how we can perform local development with Ansible and InSpec to not only verify our configuration management code, but also meet the security requirements of our fake company, MyCorp. But first, what is Test Kitchen? In case you're unaware, Test Kitchen is a free test harness that automates the process of creating a machine via Vagrant in AWS, in Azure, etc. Running configuration management code on that machine, and then running tests, in this case Chef InSpec, on that machine, and then also destroying that machine. For more information, you can see the link there, and it will also be available in the downloaded slides and in the resource list widget. So let me share my screen. I think it should be viewable. Alan, are you able to see it? I'm going to assume so. That mute button is fun to find.
Yes, we can see it.
Oh, awesome. Thanks. All right. So the entry point in defining how Test Kitchen behaves is defined in this kitchen.yaml file. The example we have here uses a Vagrant driver. The driver is the thing that decides how to create a machine. In this case, we're using Vagrant, using VirtualBox in the back end, and we're assigning it a known IP address. That way Ansible can target it later with its inventory. The provisioner in this case, it could be Chef, it could be Puppet. In this case, we're using Ansible. So we're using an Ansible playbook as the provisioner, specifying some keys and login informations, an inventory which points to that node we gave the IP address to earlier, and a playbook.yaml. Now, to verify this code, we would run the command kitchen verify. And while that runs, we'll take a look at the playbook.yaml. So here's our playbook. You can see pretty much the exact example we gave earlier, where we install HTTPD, we ensure the service is enabled and running, and we deploy the example website. Additionally, if you look at the kitchen YAML, we're going to run tests, and we're specifying our InSpec tests that live alongside of our code in the test integration default directory. And we see here our InSpec test, just like the example, verifies that HTTPD is installed, the service is running, enabled, and this demo website is deployed. If I can make this output a little bigger. What we see here is the output of the Test Kitchen run. Right now it's talking to Vagrant, which is talking to VirtualBox and spinning up a node. We should see it come up here shortly. If the demo gods are with me. There we go. So we see it come up. Oh, go ahead, Alan.
No, I was going to say, as we wait, as you want to have questions posted, please do so on the Q&A tab. So keep it going.
Yes, I won't be able to see them while I'm sharing my screen, but I'll definitely give them a look later. So what we've done here is we've created a machine. We've entered the converge phase. So behind the scene, Kitchen's actually running a few commands when you run verify. It's running kitchen create, which creates the machine, kitchen converge, which converges our configuration management code, in this case Ansible. So we're in the converge phase now, and you can see here what it's doing is it's actually installing Ansible on the node that we're deploying with Test Kitchen. Now, that may seem a little unintuitive at first because Ansible can reach out and configure machines. But by doing it this way, we allow anybody that has access to the code to be able to clone this down and run Test Kitchen. So you don't have to require a specific Ansible version on the user's workstation. So it goes ahead and installs Ansible on the remote workstation or on the remote server. So in this case, we're now into the Ansible part of the run, and this is the output the Ansible users on the webinar should be familiar with. We see here that we installed the HTTPD server, we made sure it was enabled and running, and we deployed our example website. So Kitchen Converge is ran, our code has been changed, and now we run into Kitchen Verify, which does the actual testing. And we see here our InSpec test passed just like we expect. The package is installed, the service is enabled, the service is running, and our sample website's been deployed. Now, in the traditional approach, we verified that all of the code we've written is great. So we would push this up, it'd get merged, we'd perform a security review, and the security review may or may not find something. We can move that to the left in this case. Let's assume for the sake of this webinar that our security folks have written a handy InSpec profile that we can run at any time during our software-defined lifecycle. So let's go ahead and go into the kitchen.yaml. What we're going to do here is we're going to specify a InSpec profile that's located remotely. In this case, by using compliance, we're saying fetch it from the Chef Automate server. It doesn't have to be fetched. Profile, we can come down here. We can type kitchen verify again. And this should go much quicker because the node's already created. So we see here that our test passed, but if you look here, the MyCorp security team Apache baseline, which is what would have been ran prior to deploying to production, found some things that are not exactly okay from a security standpoint, such as trace enabled being set to on, or in this case, not being set to off, server signature being not set to offs, and server tokens being not set to prod. So now we've effectively performed their security scan on our local development workstation. We can now fix that in our code. So to save watching me type for a bit, I've went ahead and created the final playbook as it would look. Let's go ahead and paste that in and give it a quick look through. Now, I'm no Ansible expert, so for the Ansible people on the webinar, forgive me if I've made any very silly mistakes. But essentially what we've done is we've added a handler that allows restarting the HTTPD service, because when we make changes to the config file, we want to make sure we restart the process. And then we notify that in each one of our tasks here. So here we've added tasks to make sure that we set these security requirements, such as trace enable, setting it to off, setting server signature to off, and setting server tokens to prod. So with that added, we should be able to come back down to our local development environment. On kitchen converge again. And again, since Ansible's already installed and the machine's already created, this should go much faster. All it's really got to do is run Ansible again. So we see here the other stuff was already changed, so it didn't need to make a change, but it did go ahead and change these things here that we were expecting from security. So now we can go ahead and run kitchen verify again. And we see here that everything is now green. So now we feel much, much safer with going ahead and deploying this to dev and then into QA and then into staging. And by the time we get to security review, they should be able to run the exact same code before they go to production. And a security review should be a non-event. It shouldn't block anybody at all because we've shifted it as far left as possible. So with that, I will stop my screen share and pass it back over to you, Alan.
Great. Thank you, Jerry. Much appreciated. And if you like that example and would like a few more details, we have a technical white paper on leveraging InSpec in Ansible instances. So that resource can be found on our chef.io resource page or on your resource tab within this webinar. And this and many more topics of interest will be shown at ChefConf coming up in a couple of weeks, actually, right? A few weeks. So for those in the Seattle area or not, if you're interested in attending, for the attendees in this webinar, we have a 10% off the registration pass if you use code HUGS for Chef. So please join me and Jerry out here in Seattle at ChefConf 2019, May 20th to the 23rd. We look forward to meeting you and many of your colleagues attending ChefConf this year. So please make sure to share the Hugs for Chef code if you are not able to attend. It would be great to meet you in person. As we wait for questions to come into the Q&A tab, please make sure to type those in as you're coming in. If you have questions coming up. One question that I have in general, Jerry, is we titled this this webinar, meaning that how you automate security in any environment with Chef InSpec. What does that really mean, in any environment? And how is Chef InSpec helping do that?
Yeah, that's an easy one. So Chef InSpec, by design, is purposely separated from whatever configuration management or deployment tool that you have in any environment. So let's say you configured your nodes with Puppet or Ansible or even Chef. InSpec lives outside of that since it just verifies the end result of the machine. So InSpec can be ran locally, remotely, via service, via a cron job, via Chef Automate. There's a lot of ways you can run Chef InSpec. So that's what we mean by it can be ran in any environment, because you can slate it in regardless of what other tools that you have currently in use.
So here's a similar question, I guess. Can you use other configuration management tools other than Ansible and Chef InSpec? Maybe like Puppet, or what other tools can you use?
Yep. I mean, just like to go with the previous question, any tool can be used. It doesn't even have to be configuration management. You can even broaden the scope past that. Let's say you have some kind of security auditing tool. You can have a second line of verification in addition to whatever security tools you have in place. Or if you have a security tool that's kind of complicated and black boxy, you can instead take the intent of that security tool and code it into InSpec code. So now anybody that knows InSpec can be able to follow the code, which, as you can see from the slides earlier, InSpec is quite easy to understand.
Okay, very cool. So how long does it take to get started with or adopt a Chef InSpec?
Yeah, not long at all, because it's so lightweight that you don't need an agent. So if you wanted to immediately get started, you could run it from your workstation. So you could say you have a couple of servers that your team manages. You could pull one of the free profiles from the internet from like say the DevSec project, or of course you could go through us and run one of our CIS profiles. As long as you have access to a profile, you can tell InSpec to go scan a remote node. So the time to first value is super low.
Sounds great. Here are a couple of questions coming in. So can InSpec be used with Kubernetes to verify compliance?
Yeah, I mean, I haven't personally encountered that out in the field, but I'm sure there is some way, because really all you need to do is be able to execute Chef InSpec. So whether you do that remotely or locally, those are all architectural concerns, but I don't see any reason why you wouldn't be able to use it with Kubernetes per se.
Okay, great. As you have any questions, please make sure to send them in the Q&A.
Yeah.
Portion.
I think I may see one as well. I clicked on the Q&A widget. That was an interesting demo, but all we've seen so far is to manually run the test yourself. Where's the automation part? In this case here, it's run manually. The automation pieces can happen via a service, via cron job. You could run it locally. Most of my experience, obviously, with Chef Automate, and Chef Automate can run them both remotely or locally. But I would recommend, as far as automation goes, that's a decision that's going to vary based on whatever your particular requirements and architectural concerns are. Whether or not you can have a node that can act as a host that can go out and scan, which if you're using Ansible, you probably already got something that can reach out and touch other nodes. So the automation then would live on that node, in my opinion.
Very cool. As you have any other questions, I think there's one more I see coming in. Are there any other questions? Please make sure to put them on the Q&A tab. So can you use Chef Automate if you're using Chef InSpec with Ansible?
Yep. I mean, absolutely. You can have it scan remotely, like I mentioned earlier, or let's say you're in an Ansible environment or some other environment where you're not using Chef. Chef Automate, essentially, at its core, is your single pane of glass or your dashboard to see the state of your entire infrastructure. So you won't be able to see the Chef portions per se, but you can absolutely have InSpec report to it. So it would still give you the ability to, host your compliance profiles in a central location and then aggregate all of your scans from your 10,000, 20,000, 100,000 nodes. You can aggregate those all in one place and search them. So you could say something like, which of my Red Hat 5 boxes, if you still have those, are not passing security requirements, or my Red Hat 6 or 7 boxes, which of those are not passing my security requirements. You could filter that via Chef Automate.
Cool. What is the benefit of Chef InSpec for the security team? We were talking a lot about operational value here, but for a security team, what would be the benefit of Chef InSpec?
Yeah, it helps you codify your intent, right? So depending on where you fall on the security team, whether you're someone who actually performs these security scans, or if you're an auditor and just needs proof of it, InSpec provides you a way to both, one, get the results in an easily digestible fashion, but two, let's say you're really heavy into the security space and you know quite a bit about what your intent is by running these scans. InSpec gives you that ability to define that in a way that's translatable. So for example, let's say you have specific kernel tunings that need to be set, like logging Martians or disabling core dumps. That's a hard thing to talk about if you're, let's say, a web app developer. So things can get lost in that translation. But if you take that intent of that requirement, or like the output of the scan isn't sufficient, you can instead take the intent of that requirement, write it in InSpec code, and you can give the InSpec code to whomever wants to view it, and then InSpec is much easier to read. They would just see, oh, it says this kernel parameter needs to be set as this, and there's a justification that I don't quite understand, but I know how to set kernel parameters. I can Google that. And then you could do that locally, make the test pass without having to be in a constant review cycle. You can self-service all of that on your workstation without having to involve other people.
Very cool. Very cool. So it's a tool for both operations and security teams, right? In different manners, but used in conjunction. Okay.
Yeah, exactly.
Very cool. Are there any other questions? I don't see anybody coming in. Any additional questions there? Any closing thoughts, Jerry, around Chef InSpec and Ansible, or otherwise?
I've got a slight closing thought. So with Ansible, there's another benefit that I don't know if I touched on too much into the webinar, where you have Ansible as the configuration management utility, and you want to scan the results of that. If you flip it around, you could instead say, let's say you're a web app developer and you know certain things need to exist on a box before you can deploy your web app. You could write that in InSpec, because InSpec's a lot easier to write, in my opinion, than most of the configuration management languages out there. You could write the InSpec test for that, codify your intent, and then hand that to your Ansible person. And then they can write the Ansible code to make those tests pass. And when you do that, you've codified the contract between multiple teams. So you don't have to have any misunderstandings in email about what requirements are. When you put all of it into code, it's unequivocal. I mean, if the test passed, then you know you've met the intent, you've met that contract, that promise between all the teams.
Wow, sounds like another use case and maybe another future webinar in the works there. So much appreciated. I don't see any more questions coming in. So Jerry, before I hand it off to April, I'd like to thank you for all the help and support that you provided in creating this webinar and your expertise, and sharing your expertise. Thank you for all those in attendance as well. So April, now it's your closing thoughts.
Yeah, thanks guys. That was amazing. As Alan mentioned, ChefConf is coming up, and it will be a great opportunity to learn more and hear about all of the awesomeness coming out of Chef. You can use code HUGS for Chef for 10% off. And also Alaska Airlines is offering flight discounts, so you can go to our website at chefconf.chef.io and find all that information. As a reminder, a copy of today's presentation and resources are located in the resource list widget at the bottom of your screen. We encourage you to download the slide deck and bookmark any links you might find useful. We, of course, hope you found value in all of the information presented. If you like what you saw, we encourage you to share the presentation with your teammates and professional networks. The on-demand version should be available by tomorrow, and we'll email you as soon as it's ready. You'll be able to access it using the same audience link you're using now. Thanks again for your time, and happy automating.